Let us now study about the power factor. Okay, so let's see first what's meant by power factor. There are some different definitions there. Okay, we'll see definitions one by one. But first you must see how this power factor comes. Okay, so we learned the formula, that is P average, that is the average power, is equal to VRMS, okay, into IRMS into cos phi. Okay, this cos phi term is this is called as a power factor. Okay, power factor. Okay, that is a basic thing you must note. Okay, how the cos phi comes, that's the power factor. From this equation only it comes. Okay, we already learned it. Okay, it's not something differently or new. So power factor cos phi, okay, you can see that is cos phi, is the cosine of the angle of lead or lag. Okay, so phi means what we saw, the angle between the current and the voltage. Okay, so this was a VRMS now, we learned now, and this was a IRMS. Okay, and then this angle we saw, that is phi. Okay, so that is the angle here, cosine of the angle. Okay, that's one way of defining it. Next one, power factor is equal to R by Z. Okay, R means what? Resistance. Okay, and Z means impedance. This is another way of defining. Next one, third one, power factor is equal to P average by VRMS into IRMS. How does this formula come? Okay, this will refer column. Okay. How does this formula come? We'll take this equation here. P average is equal to VRMS into IRMS into cos phi. Okay, you must get cos phi only. So what do? You take this VRMS IRMS down. So it will P average by VRMS into IRMS is equal to cos phi. Okay, so when you reverse it, we get cos phi is equal to P average by, that's average power, by VRMS into IRMS. Okay, so this means what? It's a true power. Okay, average power, true power, you can say, divided by this one is apparent power. Okay, so this is another way of defining, you know how it comes. Okay, so next we'll see some examples of the power factor. Let me erase the board now. So let us see some examples here. So power factor cos 0 is equal to 1. Okay, for pure resistive circuit, because phi, that angle that is between voltage and current is 0 degrees. Okay, we saw that for a pure resistive circuit, okay, the current and the voltage are in phase. Okay, so we saw the graph also now, do you remember? Okay, the voltage and the current will be in the same way. Okay, so voltage and current are in the same direction. Okay, so angle is 0 degrees. Okay, we saw phasor also, we learned now, that is 0 degrees. Okay, so cos of 0, cos of the phase angle, that is cos 0 is equal to 1. Okay, next one you see power factor, that is cos phi is equal to plus or minus 2 pi by 2. Okay, that is pi means what? 180. 180 by 2 is 90. Cos 90 is 0. Okay, for a pure L means what? Inductive or capacitive circuit. I written short forms here. Okay, since the phase angle phi between voltage and current is plus or minus pi by 2. Okay, so when you take a pure inductor, the voltage can lead or lag behind the current by pi by 2. Okay, so phase angle is 90 degrees. Okay, cos 90 is equal to 0. That's one thing. Next one, third one, power factor lies between 0 and 1 for a circuit having R, L and C in varying proportions. Okay, so power factor lies between 0 and 1. Okay, so we saw 0 means what? For pi by 2. Okay, 1 means if it's the voltage and current are in phase. Okay, so if the voltage phasor, I'm taking now the phases. Okay, the voltage phasor and the current phasor are in phase. In this case, the angle phi is equal to 0. Okay, in this case, what happens is the voltage, okay, and the current, if you see, they have the angle here, that is pi by 2, 90 degrees. Okay, so in this case, phi is equal to 90 degrees here. Okay, so this case, third one, you see, the power factor lies between 0 and 1. Okay, because the angle will be between 0 and 1. Okay, for a circuit having R, L and C in varying proportions. Okay, so it's not in resonance there. So in this case, what happens, the power factor will vary between 0 and 1. Okay, it can be 0.5 or 0.8 or 0.9, like that it can change also depending on the circuit. Okay, this is some important notes about the power factor. Thank you for watching.